My topic will focus on the air quality indoor environment of this compost barns. As the previous speaker talked, you all learned this composting process naturally release heat first. Secondly, gas release, ammonia is a major one. I think when we started the project, the background is Mike Monan, our NRCS conservation engineer, come to us saying, now we see all the barns, is that safe in terms of indoor air quality structure-wise? So this is one major objective to evaluate the safetiness of these barns. I think I will introduce myself at the beginning. I'm the extension specialist in facility and environment with the Department of Food and Ag and Biological Engineering of these universities. So basically, I'll just go through the study, what's our goal, what's the method, now what we found in terms of indoor environment, temperature, we talked about critical air speed, movement, and the air quality. Is that safe for these composting barns? Then what kind of conclusion and suggestion we have. Yeah, I think we'll talk about this. This composting process has this concern, heat, extra heat, gas release. Will that cause problems? So basically, that's our objective, try to evaluate the indoor air quality of this type of barns and evaluate the indoor environment. And then based on this to develop recommendation that will relate to structure design, will relate to the composting management, and also the ventilation management. The method, we studied 4 barns in Ohio. And for each barns, we have 4 visits, 1 per season, and that's represent the weather conditions. Then in terms of air quality, we measure many points inside the buildings and also measure before and after steering, because while steering, we intuitively think that's release of heat and gases. In terms of air quality, I think we have greenhouse concern, but we mostly focus on the safety part, the ammonia, hydrogen sulfide, and the carbon dioxide release. And because when we conduct the study, the greenhouse gas is not in our radar screen yet. Then we measure the temperature and relative humidity and at different locations. I'll show you. So the first barn we studied is in Zanesville, Ohio. They started operation in May 2006. About 160 to 170 heifers. This obviously has a smaller cow space, and but in the smaller animals. So this is some picture. This bedded areas is adjacent to the feed alleys. Based on this kind of barn, this is our sampling plans. In terms of air quality, we have this temperature sensor. I guess this is the yellow ones. The natural feature of natural ventilation is in the barn. Depends on your layout. Most barn, you have pretty uniform this temperature, air qualities. But there's a little bit of difference on upward wind and downwind, leeward. So we have 3 temperature sensors in the building along the feed alley side. Then we have one outdoors to measure the weather condition. This is continuous year-round temperature, humidity registering. And then we have this, because we cannot afford to continue to measure the gas, we have the portable gas equipment to measure 5 points in the buildings. The red is different kind of equipment, and then also the green, that's a feed sample point. So basically our design sampling philosophy is to try to uniformly sample the barn to see where's the problems, any problems. The second barn is Millersburger, and this is the barn has manure storage at one end of the building, is inside the building after the feed alley scraping of the manure, and this is the beddings. They have the Jersey cows, 150 to 160. They have 88 square feet per cows. So based on the barn, this barn layout, we have air quality, temperature sampling plan, and again, in the point, try to uniformly cover based on our measurement capability, and we also continuously monitor the temperature and red humidities. The third barn in Lodi, I think the owner was here. So it's a newer facilities, started operation 2008. This hosting cows 60 to 65. They have a large space for each cows. So it's only a bedding area, so that's our measurement point, and this temperature measurement point. And our temperature measurement is at the cow nose levels, and try to measure the cow comfort, thermal environment around the cows. The fourth one is in Mantua, and this barn has cows. It's a hosting cow too, and mixed Jersey. And then during warmer months, their cows was on pasture, and partially the cow was on this compost bed. So they have 80 square feet per cows. This is kind of measurement plans, and I think you all have handout. And the equipment we use, since we visit every season, and it's kind of portable equipment, we use this hardware anemometer to measure the temperature, the air velocities, and also temperature. This hobo sensor is kind of this sensor we drop there for season, for year round, to continuously measure that. This can have the red humidity reading too. This is an indoor air quality meter. We measure the carbon dioxide. We're also using this Kitagawa gas pump to point the check, see if they agree with the equipment. Ammonia, we have a single point monitor. There's a cam cassette inside. You can install this different, based on the ammonia level, you choose different type of cam cassette, and this one can give you the registered reading, and it also can instantaneously read the ammonia level from this screen of the equipment. Again, we also use the Kitagawa gas tube, because this kind of equipment is very simple. When you buy different type of tubes, and ammonia at different level, 20 ppm or 100 ppm level, or carbon dioxide, or all kinds of gases, there are many kinds. You can use the same kind of equipment to measure different gases. This is our team member actually staying in the barn to measure all the different kinds. So it's a teamwork. With all this field sampling work, it's a big team there. And this is called a Jerome hydrogen sulfide meter, and we used to point check, and it also can continuously run. We set the equipment in Zanesville, I guess, for 1 week to continuously measure the gas levels. We also can use this Kitagawa tube. That's kind of equipment, so it's a kind of portable equipment. This set equipment is portable, convenient, but for this Kitagawa tube, the accuracy is 5 to 15%. But this equipment is very accurate. It can measure right down to ppb levels. This is the temperature probe for the bedding measurement, and also the oxygen measurement. That's the result. For season, this different color of line represent different barns. Remember, we studied 4 barns across Ohio's. We did that for 4 seasons: winter, spring, summer, autumn. From this measurement, you can see this. Remember, most of the barns are natural ventilation. So natural ventilation barns, their indoor temperature naturally vary with the outdoor conditions. So in wintertime, and most of the barns still have this near zero temperatures. And then this in spring, the temperature quickly rise, and in summer has high temperatures, and this is in autumns. This 2 dashed line that represent the cow comfort zones. So as you can see, for natural ventilation in the spring and the summer period, this indoor temperature all are beyond this cow comfort zone. So heat stress is still a problem. So we need to abate the problem. That's why that mixing fan is important. So So when we talk about ventilation, there's one concept should be clear. When the right definition of ventilation, the air exchange, and the function of the fresh, dry air, cold air come from outside, go into the building, and pick up all the extra moisture, heat, and all the other any kind of gas, air pollutant, then you exhaust by natural force or by mechanical force, by fans. So that's ventilation, air exchange. When I'm talking about here, you have the heat problems, and then we have this mixing fan. You're adding all this large mixing fan, may not be part of the ventilation because it's steering the air, enhance the air velocity. That high velocity around the cowl will increase the heat exchange of the cowl between cowl and the air. Will abate the heat stress of cowl, but that's not part of ventilation. We call it mixing cooling fans. So if you have other gas problem, or then that mixing fan will not solve it. It will help cool cows. So relative humidities. So this is a measurement of relative humidities, and then again the dashed line represent the comfort zones. Very interesting. We studied this 4 barns. The 3 barns, except the barn 2, in the spring, don't know what reason, has very high relative humidity. But in most other times, they are in this called comfort zones. But in fall season, some barns have higher relative humidities. Interesting is this newer type of barn, barn 3 in Lodi. They have consistently lower relative humidity, which is not bad things. And so it's dry is always overall is good for this composting barns. But for cow, this is a little bit dry. Initially, I feel maybe this is our air quality meter malfunctioned. But think about the process is this is the 4-season data. Every time we measure this barn, and in a couple of days or 2 days later, we measure other barns. We use the same type of equipment. I guess maybe it's just they have newer barns. Their fans really working well, so that's why they have a little drier environment. But I think overall there's no problems. Most time this barn, they manage well within the comfort areas, and it just in fall time maybe the barn need to be it has more high moisture levels. Air velocities. So this is the air velocity in meter per second we measured. For barn 1 and barn 4, they have relatively lower air velocities. The barn 2 has the highest one. In terms of air velocity, there's no any standard for the large animal cow, because most time in spring and the summer, remember, they have the higher temperature heat stress problems. So the higher the air velocity, the better. Help them remove the extra heat. And then in the barn 2, we remember, the barn 2 was built on a tall little hill. So their long direction of barn is against this dominant wind direction. So they have very nice, good natural ventilation. Then from the air velocity measurement, you can see because that in a higher tall place and has full opening, they have a better indoor air velocity. This will help cool the cow and also help keep your bed. Remember the extra moisture released from the bedding. This will help. This higher air velocity will help remove the extra moisture from the barns. And other barns, and this barn 3 is a newer barn. They have good mixing fan. They have good air velocity too. But you can see this just by place the barn in a good location. That's really helped the indoor airflow levels. The other 2 barns are relatively low. So this is a summary of this indoor environment. And so this is our measurement averages through the 4 seasons. This is our comfort zones. From our measurement, and we noticed that in the spring and the summer season, we do need to help cow to beat the heat stress abate the heat stress problem. So the mixing fan, cooling fan is really needed. Other than that, choose a higher ground to build your natural ventilation barn, facing your long direction of the barn to the dominant wind is really a good practice, good design. On the air quality part, this is ammonia measurement in the different barns. Again, different color, different barns represent different barns in the different seasons. The highest level we get is barn 3. It's about 1.6 ppm. Again, this 1.6 ppm with the equipment is still in this resolution level. So overall, this thing is pretty low ammonia concentration. No any air quality concerns. Hydrogen sulfide, this is ppb levels. You can see the highest of this is barn 1. But this part we don't have data. The equipment is not functioning, has some problems, so we missed this. For other barn, we missed the winter conditions. But for this type of barn composting, you have a dry matter, dry manure. The hydrogen sulfide generated during aerobic conditions. It's associated with the liquid manure handling a lot. With this dry matter manure handling, you expect to have very low hydrogen sulfide level. And so we verify that.
Are all those levels in the safety zone?
Just in a second, I'll show you. Yeah, it's in the ppb levels. The highest is 12 ppbs. Carbon dioxide, it's around this 600, 400 to 600, 700 level vary, but no big change over the season. And in fall time, maybe wind stronger and it's a little bit lower, but there's no significant difference for all the 4 barns. And this answers your questions. What is standard we're checking against? OSHA has an indoor air quality standard. This is not specific for animal, for any working space. For hydrogen sulfide level, for carbon dioxide, and our measurement level is around this range. And OSHA standard is 5,000 ppms. And this NIOSH, National Institute of Occupational Safety and Health, they have this level. For ammonia, this measurement, we only have 1.6 ppm at most measured. And OSHA has 50 ppm, then NIOSH has 25 ppm. 8-hour average indoor levels. Hydrogen sulfide, we have ppb, but this is all in ppm. Based on this indoor air quality standard, we don't see any concern on the air quality. I'll tell you a story on this carbon dioxide. One day my son's school asked me, because you are in the science engineer major, come here talk to the kids on the science. So my topic is green buildings. And going there, and I saw just to increase the kids' interest, I bring this air quality portable meter, carbon dioxide, temperature, humidity, let the kids to play. When they pass back, come to me, I look at that carbon dioxide level is 2,000. And then our state has regulation that your indoor, any it is working place, even though the OSHA has the 5,000, but our general recommendations, any space indoor is to have the level, should be outdoor level plus 300. At most, don't exceed 1,000 ppm for health. But there in school, it's 2,000. And I talked to their school official, and they have somebody check, and then they return to me. They said, in the morning we come here, we ask people to check. When kids are not here, it's okay. It's only a few hundred. They said, what's the point? You should when the kids are here. So that's my because this you're full of kids in the room. That's the reason. So what I'm talking is it's barn. All these dairy barns, you have 400, 700 carbon dioxide level. It's much fresh air than, school classroom. So, yeah. This table, in your handout, right after my presentation, there's paper. In the early years, we studied this freestyle liquid manure barns, freestyle barns. This is a summary of freestyle barn, this indoor temperature in the different season. March represents spring, and June, this summer and falls. So you can see the temperature range of this freestyle barn with liquid manure storage, and also their air quality level, like carbon dioxide, 400, 500. At that time, we measure odor level. It's 100, in 100 levels, and then also the ammonia levels. It's in the 2 to 3 ppm. So based on this data and also this composting barns, we don't see any significant difference between these two types of barns, freestyle and the composting barn, in terms of their thermal environment, temperature. In this freestyle, also in summer, because you are using natural ventilation. In summertime, in the fall, you also have high temperatures. That's beyond the comfort zone too. So the mixing fan, again, the mixing, cooling fan are really needed in that time. And the air quality, no significant concerns. So that's our conclusion, basically. We talk about, we study that. As long as you follow the design guidelines, have this 16 to 18 feet tall sidewalls, manage the ventilation. I think in Mike's presentation, talk about this 1 inch opening, a 2 inch opening per 10 foot wide the buildings. And it's also, you also need to have a 1 foot opening per two sidewalls under the eave, and per 10 foot of your building width. So that's kind of rule of thumb. On the Ohio line, we have a fact sheet on how to properly design naturally ventilated dairy barns. So you may follow that guideline. At this current, based on the current study, obviously Kentucky is continuous study, and we have interesting work with them to keep studying this type of barns. But based on our current study, as long as you follow the natural ventilation design of their naturally ventilated dairy barns, we don't see any air quality concern. But you do need to keep working on the heat stress problem in the warmer months. So this project is funded by NRCS and also Ohio Dairy Research Fund. And also thank you for all the participants, our dairy producers, and they're very supportive to our studies. My contact information is here, so if you have any question in terms of Mike's presentation, I'm happy to work with Mike to address your questions.